So good morning students, welcome back. Today we'll start new chapter, lesson number 10, wave optics. Okay, so let's start with Huygens principle. One of the most important topic, Huygens principle, Huygens wave theory. What is Huygens wave theory? Look at students, it states that each and every light source, point light source, S is a point light source. Okay, it emits spherical wavefront. We know very well. Point light source always produce spherical wavefront. Okay, so S is a point light source, is produce spherical wavefront. Okay, and it travel like this. So the very first point of Huygens principle is each and every point light source emits the light wave. That is called primary wavefront. So look at this circle is representing primary wavefront. Okay. Each and every light source emits the wave. Gradually, circle becomes large. So that wave is called primary wavefront. That is our first point. What is second point of Huygens theory? Second point is each and every particle. Look at students, that is important point. Each and every particle of primary wavefront behave as a new source of light. So it again emits the wave. And that is called, these circles are said to be secondary wavefront. Okay. So two main points. The first point is what? Each and every light source emits wave, spherical wave. These are said to be primary wavefront. And each and every particle of primary wavefront behave like a new source of light. It again emits wave. These are called secondary wavefront. Okay. The third point is primary and secondary wavefront travel in medium with the speed of light, that is 3 to 10 raised to power 8 meter per second. Okay, and after traveling so long distance, we know whether the cylindrical wavefront or spherical wavefront, when it travels long distance, it will convert into plane wavefront. Fourth point of Huygens principle is primary wavefront and secondary wavefront will spread in all directions throughout the medium. So these are Huygens theory, Huygens wave theory that explain about the wavefront. Okay, it states that each and every point light source always emits wave, that is called primary wavefront. Okay, and each particle of primary wavefront behave as a new source of light. It again emits wave, that is called secondary wavefront. Primary and secondary wavefront travel in medium with the speed of light. Okay, and as like primary wavefront, secondary wavefront will also spread in all directions. So this is a small description about Huygens wave theory. Okay, students. Now, students, we'll discuss the application of Huygens principle. We are having two applications. The first application is what? To verify the laws of reflection. It means we have to prove the laws of reflection. Okay, so let Mn is a reflecting surface. Mn is a reflecting surface. Okay, a ray is incident, it get reflect. Another ray is incident, it get reflect. I drawn two perpendicular, A, B and A dash, B dash. I drawn perpendicular on wavefront. Okay. N1 is a normal, N2 is a normal. Angle between incident ray and normal is called angle of incident I. Okay. This angle is 90. If this is I, this will be 90 minus I. This angle is 90 minus I. This one. Okay. This is again 90. If this is 90 minus I, remaining will be I. Okay, students. So we can say this angle of incidence. Same like angle between normal and reflected ray is called angle of reflection R. So this also angle of reflection R. We'll take two triangles, students. Actually, AB is representing incident wavefront and A dash B dash is representing reflecting wavefront. Okay. So we'll take two triangle A, B, A dash and triangle A, B dash, A dash. In both the triangle, angle B equals to angle B dash. Why? These two angles are equal because in right angle, 90 degree. Okay. Second thing, A, B, A dash and A dash, B dash, A having common base A dash. So A dash is common base. Okay. We prove two component equal. Now the third one, B, A dash will equals to A, B dash. Why? Because what is the form of distance? BA dash, that is distance, speed into time, and we'll take the light speed. Okay, that is C, CT. And AB dash, that is also the speed of light, C to T. So in triangle ABA dash, the side BA dash is CT. And in triangle A dash B dash A, the side B dash A is also CT. Distance what? Speed into time. CT. So two triangle having three component equal. When two triangle having three component equal means what? They are congruent. They are congruent. So remaining side and remaining angle will also equal. So in triangle ABA dash, angle A should equals to, in triangle A dash B dash A, angle A dash. Angle A is I, angle A is R. And we know very well, incident angle always equals to angle of reflection. That is second law of reflection. So what we verify using this Huygens wavefront diagram, we verified the laws of reflection. Okay students, verify laws of refraction. A rays incident, it get refract. Another rays incident, it get refract. AP is representing incident wavefront, okay, and A dash B dash is representing refracting wavefront. I drawn perpendicular. N1, N2 are the normals. Angle between incident ray and normal is called angle of incident I. This is I. This will be 90 minus I. So this again I. Okay. Because this is 90. If this is I, this will be 90 minus I. Okay. This is again 90. If this is 90 minus I, that is I. Okay, students. Same like angle between normal and refracted ray is called angle of refraction R. This is 90. Okay. So this is 90 minus R. This is again 90. If this 90 minus R, that will be R. Okay, students. So now students, this is air, ray medium, this is glass, denser medium. Speed of light is C1 in red medium and C2 is the speed of light in denser medium. That's why this distance is taken as C1t. What is the formula of distance? Speed into time, C1 into t. And that distance will be what? C to t, speed into time in denser medium. Now I'm going to use this upper triangle. In triangle ABA dash, I'm applying sin I, perpendicular by hypotenuse. 90, so perpendicular is what? B A dash, opposite to 90, A dash is hypotenuse. This is okay. In this lower triangle, again I apply sin R, perpendicular by hypotenuse. So perpendicular is what? This A B dash is perpendicular and opposite 90, A dash is hypotenuse. Okay. Now first equation divided by second. Sin I divided by sin R, left hand divided by left hand and right hand divided by right hand. A dash to A dash cancel out, B A dash by A B dash. What is B A dash? This distance is C1t. A B dash, this distance is C2t. T and T cancel out and look at speed of light in one medium to speed of light in another medium is called refractive index of that medium, represented by mu. Sometimes it is also represented by n. So sin I upon sin R equals to mu. This is called second law of refraction. That is also said to be Snell's law. So using Huygens wavefront, what we prove? We mathematically prove the laws of refraction. Second law of refraction, sin I upon sin R equals to mu, where mu is called refractive index of that denser medium, and this is said to be Snell's law, second law of refraction. Okay, students.